Let's start with a super easy factoring problem to warm up. And that's check and see if this is factored right. Well, you might be like, well, what was the question? I'll tell you the question in a minute. You're supposed to be checking. You think you factored it right. But this is the part where you would check it to make sure you factored it right. So what are you supposed to do? You're supposed to multiply it out. Another way I could have said the question is, put this equation, if I put a y equals in front of it, put this equation into general form. That's another way to say that. It starts at 2x squared. So that's probably the most important factoring skill, is knowing how to check it at the end. Basically, that's just. All right, would you check with the kid next to you and see if you got the same thing as they did? Okay, so I'm going to do the outside is negative 10x, and the inside is plus 3x. I'm going to just take the time to put them together right now. Negative 10 and plus 3 makes negative 7x. See, I'm just trying to save a little bit of time. And then the last one's minus 15. Raise your hand if you had that one right. Awesome. Now let's talk about what these different forms are good for. This one tells you the x-intercepts. I'm not asking you to find them right now, but I know you could. The x-intercepts for this one, for instance, would be 5, 0. And for this one, it would be negative 3 over 2, 0. All right, you can find x-intercepts from that. Last hour, 0 people knew what this was good for. Does anybody in here know what the general form's good for? Doesn't tell you the vertex. It doesn't tell you the x-intercepts, but it tells you something. Ooh, a couple people know. Yay. What do you think, Quinn? It tells you the y-intercept. Yes, that's what it's good for. It's sitting right there. Now, you could argue that all of them could tell you the y-intercept if you stuck in x as 0. But this one, it's just sitting right here. So yeah, y-intercept's handy on that one. And of course, vertex form is good for, giving you the vertex. So don't forget that that's got the vertex built in right there. It's just not negative 3, 6, it's 3, 6. Okay, so that's what these forms are good for. All right, next thing. Can you handle these 5 factoring problems? All right, here's number 1. X squared minus 36. That factors. 2 sets of parentheses. Hopefully not super hard. Number 2. 3x squared plus 10x plus 8. Number 3. X squared plus 3x. Now I know it feels like, but what's the last number? You don't even have to put a 0 there. You can just factor the GCF out. Don't think, oh, got to put 2 parentheses. You don't always have 2 parentheses. Just factor out the common factor. That's number 4. And that, number 5, is like the hardest thing we would ever ask you to factor on the list. That one might be a challenge. But if you figure out what the GCF is, and you pull it out, it won't be that bad. So I just gave the students this puzzle, gave them these clues. The axis of symmetry is at 4. The vertex is at 4, -2. By the way, this will always be true. If you haven't caught on to this, let me be the first one to tell you. The axis of symmetry, that number, is always the same as that number, the x of the vertex. So if you ever like later, maybe even this hour, if you're ever wondering how to get this number, you just stick in the x into the equation that you have. But my challenge to the students was, can you write the equation for this? And since you have the vertex, you should have gone right for vertex form. X minus 4 squared minus 2, and it'd be really easy to forget something. Jack, you know what I forgot? Something's wrong with my equation here. The 2. Vertical stretch by a factor of 2. Should be a 2 right there. There you go. Raise your hand if you got that one right. Awesome. That's called vertex form. Now, my challenge to you is multiply it all the way out. That'll give you general form. And if you're forgetting how to do that, this x minus 4 needs to be split into 2 x minus 4s. And then factor it. You might think this is factored. It's not factored. It's not factored because it's got that -2 at the end. So this isn't factored form either. Multiply it all the way out and then it will factor. How many of you are already done with that? All right, take a minute. We only have 2 people done. Multiply it all the way out and then factor it. I'll pause while you give that a shot. Okay. Caleb, what'd you get for the general form?
2x squared minus 16x plus 30.
I think he's right. Do you guys think he's right? Mm-hmm. All right, awesome. All right, next up, Jonah. Could you factor the 2 out of everything?
Yeah.
So I just want to remind everybody how that would work. You divide everything by 2, but then you really have to put the 2 in the front, and that's really common for people to forget that. That 2 has to be in front then from now on. And you would get x squared minus 8x plus 15. And then a bunch of kids got stuck factoring ones like this. How many of you were able to factor this? Raise your hand if you were able to factor it. All right, if you didn't know how, I want to remind you. You start with the x and the x. You look at this number, and that tells you you do not use a plus and a minus. It either has to be plus plus or minus minus. And this time it was minus minus because there was a minus. Here, they have to be some negative in it, and therefore there has to be 2 negatives in it. And usually that's the problem, is people don't do the signs first. If you do the signs first, then it's 5 and a 3, and it's not that bad. That makes -8x. Yay. Okay. You have practiced. You now need to do some on your own without me, like, leading you through it. So I'm going to show you what the homework looks like, and I'll tell you which ones to skip. We'll do the first problem together. It's just kind of vague. So I want to tell you, here's an equation in vertex form. Just copy this one. Y equals x plus 3 squared plus 5. And then what's this used for? Like, why do we have this form of an equation? It's not that hard. What's built into the equation? The vertex. So it's used to identify the vertex. Ooh, Shocking. It's called vertex form. All right, here's one that's in general form. What's that good for? Somebody said it earlier this hour. Y-intercept, good. And here's one in factored form. Has that got the y-intercept just staring at you? No. Does that have the vertex just staring at you? No. It's got something else. X-intercepts. Would you have been able to answer those questions? If you understood, you just have to make up your own for this. It's not that hard, is it? All right. Will you be able to find the vertex on this? Oh, I hope so. The only problem is you have to be smart enough to know what's in between 0 and -2. That must be -1, right? So then if you're going to identify the vertex, you're like, it's right there. Yeah, well, what is it? It's 2, comma, -1. The axis of symmetry, that always goes with the x of the vertex. All right, I'm going to encourage you to do 2 and 3, but you can skip all of number 4. So everybody go and cross off a couple. Does this mean you are not allowed to do that? Of course you can do it if you want, but I'm saying it's probably overkill. So we need to make this assignment a little more doable. We're going to cross off 5D and 6D. And then there was a whole bunch of problems that are all really valuable, important practice, and I couldn't have you skip them. But number 12 is it's like a double up of number 10. There's 3 that are kind of like that. So we're going to cross off 12. So I carefully chose which ones to cross off. But if you want extra practice, there you go. It's like a little mini worksheet. 3 questions you could do if you want extra practice. All right. Now, this is kind of longish, but it's not, honestly, the questions are pretty quick. You'll find that this won't take you that long. And you have a bunch of time in class. So this is the part where I hope and pray that you will come up and ask me for help. Because I want to help you, but I can't force you to tell me that you're struggling. And then last thought is, if you're really, really struggling, you should get help today and come in tomorrow morning. Because Thursday mornings, my open hours, my office hours. So you can be here in my room, get full, like almost an hour of help. All right, that's all I got for you for today.